Okay, so today we're going to talk about section 1.4, operations with fractions and mixed numbers without using a calculator. Does that induce fear for you? It's okay. We're going to be all right. Let's talk about rational numbers first. So a rational number is a number that can be written as a fraction, a over b, where a and b are both integers and b is not 0. Now, why can b not be 0?
Because anything divided by itself is always 1.
Almost. Because anything divided by 0 is undefined. We don't have a way of dividing something into 0 parts. Right? How would that work? Let's imagine, because, food. Imagine we have a pizza, a whole pizza. How can you divide that pizza into 0 parts? You can't. It already starts as 1 part.
Oh, okay.
Yeah.
Okay.
So we can't have division by 0. Every integer, every negative and positive whole number is also a rational number because we can put it over 1. Because anything divided by 1, as Barbie told us, is itself. Right? Any questions about what a rational number is? It's just a fraction. We've seen fractions before, right? Are we afraid of fractions?
Yes.
A little bit. We're going to be less afraid of fractions after today. That is my hope. So, the first thing about fractions we're going to talk about are equivalent fractions. And fractions that are equivalent are fractions that represent the same amount, the same quantity. So if I have 1/3, that's equal to some number of twelfths. What would it take to get from 3 to 12? We would multiply it by 4, right? So if we multiply that by 4, we get 12. What if we multiply 1 by 4? We would get 4. 4 over 12 is the exact same thing as 1 over 3. Okay, those are equivalent fractions. Now, if we look at the next definition, lowest terms, that's when the largest factor that the numerator and denominator have in common is 1. Okay? So if we look at 4 twelfths, do they have a factor in common other than itself and 1? The common factor other than 1? They do, right? They have a 4 in common, right? So that can't be in lowest terms. 1 and 3, on the other hand, what factors do 1 and 3 have in common? Just 1. So this fraction is in lowest terms. And that sort of makes sense that 4 twelfths would not be in lowest terms because we had to take 1/3 and multiply it by something, right? Up and down for yes, side to side for no. Okay, a mixed number. A mixed number is what we have when we have a whole number and a fraction together. And we treat those as though they're just added together, but they're side by side. Okay? So, if we have 2 and 2/5, what could we do to write that as a single fraction? So we could multiply this 5 times the whole number. We multiply the denominator by the whole number. Let's write that. And add the numerator. So 2 times 5 is 10 over 5 plus the numerator, 2 over 5. And 10 plus 2 is 12. Don't worry, we'll have plenty more examples of that. Annie, you signed in, but you didn't let Barbie sign in.
What?
You signed in.
Oh, I thought she ended it.
I didn't even touch it. I didn't even know it was here.
My bad.
All good. I just ended y'all's friendship. Doubtful. Okay, simplifying fractions. Why is 21 over 28 equivalent to 3/4? Why are those equivalent?
Because they can both be divided by 3.
So,
No, that's not right.
so what does it mean for them to be equivalent? Go back into your notes. Yes, equal. I agree. But what does the definition for equivalent fractions say? Fractions used to represent the same quantity. So we're saying that 21 over 28 and 3 over 4 represent the same quantity.
Oh, it's like 2 by 4s. Okay. Sorry.
Is that a wood joke?
No, it's actually a thing. Because they usually measure, like, for instance, if you have a 4 by 8 sheet, they count it by 23 over 30 seconds, and then it's 3/4 loops. So it's a half sheet.
Take your word for it.
Alright.
So, do these two have something in common? Do they have a factor in common? What'd you say? They don't have a 2 in common. 21 is odd. No, 28 doesn't have a 3. If you keep guessing high enough, you'll get there. Keep going. It's not 4, right? Because this one's odd. It's not 5 because neither of those are 5 or 0. 7. 7 is the number. So 21 is 7 times what?
3.
Okay, and 28 is 7 times.
4.
Okay, so if we canceled out those 7s, what would we have?
3/4.
3/4. That's why they're equivalent. So if we simplify it and we reduce that fraction by taking out its common factor in the numerator and denominator, we'll get to this simplest form. Okay? So let's do the same thing with 18 over 30. What factor did those have, or what factor did 18 and 30 have in common? They have a 6, I agree. Who said 6? Who said 6? You said 6? Okay. Okay, so 6 is correct. So 6 times what is 18? 6 times 3. And 6 times what is 30?
5.
Okay, what can we cancel? We can cancel those 6's. So what is our result? 3/5. Now, how do we know when we're done reducing?
It can't go any lower.
When we don't have any more common factors, right? It can't go any lower. What do 3 and 5 have in common?
1.
They have a 1, and that's all. Both 3 and 5 are, there's a special name for numbers that only have themselves and 1 as factors. Starts with a P, ends with rhyme.
Prime.
Prime, okay. Good. What about 12 over 36? Do you think you could do that one on your own? Oh, hang on. Do it on your own. Do it on your own. Do it on your own. Practice. I can't get you to talk for 10 minutes and then you won't stop. I like it. You good? Okay. You just look like you're a little tired today. You all right? Okay. I'm a little tired. I'll be honest.
I hope I did this right.
We'll find out, won't we? We ready to work together on it? What do 12 and 36 have in common?
Four.
They definitely have a 4 in common. Let's try that first. So 4 times what is 12?
3.
4 times 3, no.
4 times 3 is 12?
Yep.
Right.
You're good.
Oh,
I said no because I wrote it bad.
oh.
You're good. And then 4 times what is 36?
9.
My line corrected itself, but it looked ugly to begin with. So what do we end up with? 3 over 9. Are we done? No. And I'm glad you chose 4 this time, because that gives us an opportunity to reduce a second time. What do they have in common now? 3. So that's 3 times 1 and
3 times
3 times 3. So what cancels?
3. The third is back.
And what are we left with?
1/3.
1/3. 1/3. And can we reduce that any further? We cannot. What?
I got it wrong.
Yeah, what did you put?
3, 4. Because I did 2.
2 would have worked. You would have 2 times 6 and 2 times 18.
Oh, that's why I did 12.
Okay, adding and subtracting like fractions. So if we add and subtract like fractions, what is a like fraction? A like fraction is a fraction that has the same denominator. Okay? So what is a like fraction? They both have the same denominator. That matters here. What we do is we add or subtract the numerators and keep the denominators the same. Simplify if it's needed. So basically, we're talking about, and I'm just going to relate it back to pizza because why not? Because food, because I'm hungry, okay? Don't judge too hard. So if I have a pizza that's cut into 8 pieces, and I have 1 piece and then 5 more pieces, how many pieces do I have? Mm-hmm. We have 6 pieces, right? So that's 6 pieces. But the pizza is still divided into how many pieces? It's still divided into 8 pieces. And that works just fine, right? Because they have the same denominator. Now if we have 19 out of 24, so now we've divided whatever our whole number is, our pizza, into 24 pieces, and I have 19, and then I give you 1 piece. I take 1 piece away. How many do I have left? 18 out of 24. Now, in both of these cases, am I done? No, because both of these fractions will reduce. So let's start with the first one. What do 6 and 8 have in common? They have a 2 in common. So 2 times and Annie, tell us what it is. 3/4. You were just one problem ahead. That's what you got on the last one, right? See, you knew the answer for this one.
I wrote it 12 instead.
It happens. Could have easily happened to me. What about 18 over 24? What do those have in common?
9?
They definitely have a 2. They also have a 6. Which one do we want to do?
6.
Okay, 6. 6 times what is 18?
3.
And 6 times what is 24?
4.
6 is canceling. What do we have?
3.
So those are the same value. Any questions? So when we're adding and subtracting like fractions, like denominators, what do we do?
Keep the denominator the same.
Keep the denominator the same and
Simplify it.
skip one step. Add or subtract the numerators, the top part. Okay? That's beautiful because that works really well, right? No trouble. We know how to add and subtract like fractions. But what happens if they don't have the same denominator? Say that again. LCD, least common denominator. And this is what really trips people up the most, okay? So if the fractions we're adding or subtracting have different denominators, then both have to be expressed as equivalent fractions with identical denominators before we can add. So no matter what, when you're adding and subtracting fractions, you have to get where you have the same denominator. You have to make them look like fractions. So the common denominator for a set of fractions is determined by finding the smallest number, called the least common denominator, that is a multiple of all of the denominators. So what is a multiple? Those are numbers. What's a multiple? Like, what's a multiple of 2? 2, 4, 6, 8, 10. Okay, those are the multiples of 2. What are the multiples of 3?
3, 5, 7, 9.
3, 6, 9, 3.
No, wait a minute.
3, 6, 9, 12,
Yeah.
15. Okay. What about the multiples of 4?
4, 8,
12.
Wait a minute, we said what now?
Multiples of 4.
Oh, go ahead, y'all.
You just get your pencil ready.
I thought I would go to jail this morning because I had grand jury. They gave me 2 grand jury things to do. They got 1 to 12 for me to come to grand jury. And today, and I thought I was coming. Y'all sent me 2 of these. And they said, well, you going to have to go to jail today. So I was sit there and waited. And they said, no, you didn't got to go. We found out you didn't got to go to jail. You missed grand jury.
I don't think that's how that works.
Well, they sent me 2 of those. 1 today and 1 12.
Bless your heart.
Yeah, I don't know who these folks is, but I'm still going. See who's going on 12.
Okay, so let's talk about multiples some more. So let's write us a list. So let's start with 2. So what are our multiples? 4, 6, 8, 10, 12, 14, 16, and so on. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24. Multiples of 4 are 4, 8, 12, 16, 20, 24, and so on. I'm adding a ... at the end of those just to signify that they continue going. 5 is 5, 10, 15, 20, 25, 30, and so on. I'm going to go up to 6. 6, 12, 18, 24, 30, 36.
I see a lot of 12s in there.
It's pretty common that we'll end up with 12
Mm-hmm.
because 12 is a multiple of a lot of things, which is good, right? That means that we'll end up having an LCD of 12 a lot. But not in this example. We have 3/10 plus 1/4. You need to be writing instead of talking. Would it be helpful to have an LCD, like a multiple cheat sheet,
Yes.
like this that goes higher than 6?
Yeah.
Remind me as soon as we get done with the lesson, and I'll create it. And I'll print it out, and you'll have it. Now, you can't use it on your test, but it'll help you practice as you're going through to get you better at recognizing those. I do. Your first test is tomorrow. I'm just kidding. Just kidding. See how much better you feel about it now that you know that it's not?
I was gonna cry.
My heart stopped. Right? Well, I just felt like my heart singing.
So it's supposed to be Thursday.
This Thursday?
hmm
This Thursday?
Thursday the 23rd.
So you gonna let it be
Like I
Thursday?
said, I slept it. Do you have class on Thursday? No, right?
No, we don't have class on Friday. We will probably move the test to Monday. That way you have the weekend to study for it.
Thank you.
I'm not a mean person most of the time.
I'm driving up to Arkansas, so I don't know if I'll be there for this.
What?
I have to drive up to Arkansas this Friday.
So you don't know if you'll be what?
I don't know if I'll be here on Monday.
What?
Can I take the test online?
We'll talk about that later.
Okay. I gotta go spray my uncle's ashes.
We'll talk about it.
Sorry.
3/10 and 1/4. What's our least common denominator?
1. No, 4.
2.
Read. Hold it, man. I'm reading back.
Hold on. Let's go back up. Our least common denominator. That is a multiple of all of the denominators. Okay? So we're talking multiples of 10 and multiples of 4. So 10, 20, 30, 40, 50, 60, and 4, 8, 12, 16, 20, 24, 28, 32. Do I need to keep going? I don't, right? What's the smallest one they have in common? 20. So our LCD is 20. 20. Our LCD is 20. So now we need to convert that 3/10 into 20ths. So this is the way we're going to set these up every time. Okay? What do we need to multiply 10 by to get 20? 2. So the thing we're going to multiply by is 2 over 2. So when we have 2 over 2 in there, we do 10 times 2, which gives us our denominator of 20. and 3 times 2, which gives us our numerator of 6. Okay? So when we get ready to add these, 6 over 20 is going to replace the 3 over 10. So how do we change 1/4 into 20th? Who said 5? Yes, it's 5. What goes in the numerator? Also 5.
Yeah,
Okay, 1 times 5 is
5.
5. Very good. Now we can replace both of these fractions. And so we'll say 3 over 10 plus 1 over 4 is equal to 6 over 20 plus 5 over 20. Now we have the same denominator, right? So we can leave that the same. And what do we add?
6 and 5.
We add the 6 and 5 and we get
11.
11. So your answer is 11 over 20. Any questions?
Okay, I'm in the question.
A lot of work.
The 3 over 10 plus 1 over 4. How you get this?
Say that again.
The 3 over 10 adding 1 over 4. How you get 6? I'm still trying to catch up with.
How did we go from 3/10 to 6/20?
No, the 310. 3 over 10 plus 1 4.
That was our original problem up
Okay,
here.
Okay, gotcha now. Gotcha.
So I just went from here to here with it.
Okay, gotcha.
Okay. Now, I want you to work on this one on your own for just a few minutes. Give that a try. We have 4/7 minus 1/3. Okay, what's our LCD? 21. How did you guess that? You didn't guess it, right? I hope.
7 times 3 is 21. 3 times
3 times 7 is 21.
Mhm.
Okay, so if we take 4 over 7, we need to multiply by what? 3 over 3. And that gives us
12 or 21.
12 over 21. And 1/3, we multiply by 7 over 7. Let's be very clear that it's 7 over 7. It's got to be something equal to 1. And that gives us 7 over 21. Okay, so when we replace that, we get 12 over 21 minus 7 over 21, which is
21.
5 over 21. How do we feel about that? It was supposed to be a rectangle. There we go. Any questions about how we found that difference? You good? You're tired, aren't you? All right. Determine the difference. Now we have 7/8 minus 5/6. Any thoughts?
I need to go back 1 each. 1 each.
So what do 8 and 6 have in common? What's their first common factor?
Gotcha.
Wait.
Hey, you got it coming.
Annie? What is the first one? No? Jenny?
There's division.
Okay. The question is, what is our LCD? 24. How can we be sure?
Because
We're just guessing numbers right now, right? That's what's sort of happening.
no,
You wrote a list. So, our multiples of 8 are 8, 16, 24, 32, 40. Our multiples of 6 are 6, 12, 18, 24, 30, 36. The smallest one that's common to both
24.
is 24. All you have to do is do the list and pick the one they have in common. That's why I thought it would be a good idea to build you a list, like a paper that you can look at and say, okay, here are the multiples that make sense. Get you some practice. Okay, 7/8 needs to be multiplied by what to get to 24ths?
Sometimes 3. 21.
21 over 24, okay. It's Lindsay, right? Right? Can you tell me the next one? 5/6 times what? Gives us 24ths. Is your name Lindsay?
Oh, I'm sorry.
That was excellent ventriloquism, by the way. Yeah, 4 over 4. 5 times 4 is 20. So if we're doing subtraction, I'm just going to bring myself a little arrow here. That's terrible. But equals 21 over 24 minus 20 over 24, which is 1 over 24. How do I know it's 1?
because you're subtracting the numerator and the denominator stays the same.
Exactly. So 21 minus 20 is 1. Does anyone have any questions about adding and subtracting fractions? Speak now or forever hold your peace. I believe in you. So let's summarize what we've done. The crux of everything is that we can add or subtract fractions when we have what? When they have a common denominator. When it's the same, we can just add or subtract those numerators. In the event that they're not the same, we have to multiply by some number for each one that is the least common multiple of both denominators, or the least common denominator. Okay, let's talk about something that's a little bit easier. Multiplying fractions. Multiplying fractions involves multiplying numerators and multiplying denominators. On your end, it probably has the little dot here instead of the box. Hopefully, does it? Good. It just didn't render right from PowerPoint. So, common factors in the numerator and denominator can be divided out either before or after we multiply. So if you want to reduce before you multiply, that's fine. You can also reduce at the end. So if I have a fraction a over b times a fraction c over d, what I do is I multiply the numerators together and the denominators together. So it's top times top, bottom times bottom. Questions? Anybody? Someone has something they want to ask. No? We're good. Okay, so let's look at what we get. So if we have 3/7 times 2/5, what are we going to do? Tops times top, so 3 times 2 over 7 times 5. And what's 3 times 2? 6. 35. 6/35. That's how you multiply fractions. Now, if it can reduce, then we'll have to reduce. But do 6 and 35 have any common factors? They don't, so we're done. Put that in a box so it doesn't escape. Put it in fraction jail. Okay. Can you do 5/6 times 2/3? How does that work? 5 times 2, 6 times 3. That gives us 10 over 18. Now that will simplify, right?
Right.
We can divide both by 2. So 10 divided by 2 is 5, and 18 divided by 2 is 9. Would it help if I wrote this out as 2 times 5 over 2 times 9? Is that better? And the 2's cancel. So we're left with 5/9.
Oh, yeah, I don't know what it is. I'm not awake yet. Okay. Can't you just like cross, like, get the 2 and the 6 out the way and do like 1/3 or something? And then
You could. So that is exactly what the previous slide says, is that if we wanted to, we could make this a 1 and this a 3. You could divide those out by those factors out in the beginning. 100%. What about this guy? I'm sorry, say that again. The 1 by the 10. So we multiply the 1 times 10 and add 3. So what does that give us? 13 over 10 times 5/9. I see consternation on several faces.
Because you do
So
10 times
the whole number times the bottom That's 10, right? So we'll have 10 over 10 plus 3. 10 over 10 plus 3. So 13 over 10. Now this time I am actually going to reduce before I go to the next step. Just so you can see that. So the 10 and the 5 both have a common factor of 5. 10 divided by 5 is 2. 5 divided by 5 is 1. So now we can multiply 13 times 1, which is 13, and 2 times 9, 18. Now can we reduce any further?
No.
How do you know for sure?
Least common denominator.
Least common factor, maybe.
Least common factor.
Or they don't have any
I mean,
factors.
least common thing.
They don't have any factors in common. 18 and 13,
Yeah.
and that's because 13 is prime. 13 is the first double, no, it's not the first double digit prime. 11 is. Anyway, it is a prime number. Okay, any questions? So we're about to talk about a new topic called reciprocals. It's not stressful. It's simple. I would tell you if it was complicated. I would be honest. So, what is the reciprocal of 7? What does a reciprocal mean? It means to make it a fraction and flip it.
1 7.
So 7 is 7 over 1. When we flip it, 1 7. If it's already a fraction, it makes it very easy, right? 16 over 3 is 3/16. Now 3 and 5/8, a little 3 times 8 plus the 5. We can't flip it yet. So 24 plus 5 is 29 over 8. So our reciprocal is 8 over 29. Don't turn the page yet.
Wait, how did you get 29?
So
And then plus
3 times 8 plus 5 over 8.
Do you always keep the same denominator?
Yes. Yes, you do. So I'm going to write that 3 times 8 plus 5 over 8.
I just go like the 8 times 3. I do a little multiplication sign, and then I go above the 3 and add, do an addition sign in between. That's how I come up with it.
Whatever it takes, as long as you know. With reciprocals, we just spend our time going into the upside down.
I just have to click.
Anyone familiar with the upside down? Stranger Things? I have any Stranger Things fans in here?
Oh, aren't they having
A new season.
no, I thought they were having a thing in Houston,
Are they really?
no, like a show, a theater of it,
All right.
of Stranger Things.
I'm in.
Yeah, seriously, look it up.
I will. 100%. All right, dividing fractions. It's not that bad. That's why I talked to... So, division by any non-zero number is equivalent to multiplication by its reciprocal. That's a lot of math words. Here's what I want you to write. Dividing fractions is as easy as pi. Flip the second fraction, then multiply. Dividing fractions is as easy as pi. Flip the second fraction, then multiply.
that rhymes.
On purpose.
But are we talking about pie since we're in math? Is pie like we're putting before we talking about pie?
No, we're talking about like delicious pie of your choosing.
No. Is dividing
Flip the
fractions
second
we're gonna do
fraction.
keep, change, flip?
It is.
Flip this.
Also, keep, change, flip.
Okay, so 7 divided by
So what do we do if we have a fraction a over b divided by c over d?
flip the second fraction that you multiply.
We take,
It's gonna be d over c, right?
yeah, this is
That's not right.
not right. Just forget that that exists. It's going to go to a over b times d over c, which is a times d over b times c. Yeah, I'll fix that in the notes for the future.
That's what I had done last time.
Okay, keep, change, flip. So now that everyone should already have this stuff, I'm just going to make it smaller. If I have 7/8 divided by 14/16, now you may be tempted to reduce first. Don't do it until you have multiplication, okay? Because it's going to flip and mess everything up for you. So we're going to keep the first fraction, which is 7/8. We're going to change division to multiplication. And we're going to multiply by the flip of 14/16, which is 16/14. Now that we have multiplication, now we can reduce if we want to. And we probably want to, right? So, what can I do?
The 8 and the 16
So-
will be 1 and
1,
it'll be
1 and,
8,
Yeah.
1/4.
okay, 8 divided by 8 is 1. 16 divided by 8 is 2. Okay,
And then
we can divide,
7 and 14.
what can we divide those by?
7.
Okay, 7 divided by 7 is,
1, 2.
14 divided by 7 is 2. So we have 1 times 2 over 1 times 2. What is 1 times 2? And 1 times 2? What's 2 divided by 2? 1. There you go. Okay.
So then, is that a 7 over there?
Yes. So this doesn't change. Are we good? Up and down for yes, side to side for no. Okay. So, if we're talking about dividing fractions, recall that the reciprocal of any non-zero number n can be written as 1 over n. The product of any number and its reciprocal is 1. Okay? So, if the original number is a fraction, its reciprocal can be written as the fraction b over a because a over b times b over a is 1. So literally whatever number you flip it, it gives us the reciprocal. We've already talked about that. Let's divide some more fractions. We'll do this one together and then you can work on the next one alone. So What do we do with 2 3/4?
We multiply 4 and 2,
Which gives us 8.
8,
and then
and you
add
add
3.
3, you get 11 over 4.
11 over 4 divided by 3/8. Then we keep change flip. So keep the first one, change to multiplication, and flip 3/8 to be
8, 3.
8/3. Is there anything we can reduce? The 4 and the 8 have what in common?
4.
So 4 divided by 4 is? 8 divided by 4 is?
2.
2. So our final multiplication is 11 times 2 divided by 1 times 3,
Equals 22 over 3.
22/3. Now that you have that framework, I'd like for you to do 4 2/5 divided by 2. Take just a few minutes to do that. We need just another minute or so. Are we good? Anyone want to say anything out loud? Whoa, 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 whoa.
Well, I thought you said to say it out loud.
No, I said, did anyone want to say anything out loud, like, other than just a head nod? But
Oh, I forgot to flip, and then I had to redo it.
but you got it in the end.
Correct.
Sorry.
Your shoes are really bright.
Oh,
Just noticed them.
I forgot to check.
Okay, so if we're going to go from 4 2/5 to an improper fraction, what does that look like?
You want to multiply 4 times 5, and then you going to add 2.
Which gives us,
22 over 5.
okay,
Divided by 2 over 1.
divided by 2 over 1.
Equal 11 over 5.
no, flip.
Now we need to keep change flip, right?
Yeah.
So 22 over 5 times 1 over 2.
Two, yeah.
Multiply. Or you can do it now or later, but you said
Let's
not to.
Let's do it later on this one.
Yeah.
Let's do it later on this one. 22 times 1 is
Use 22.
oops, over
10.
10. And what did 22 and 10 have in common?
2.
They have a 2 in common. So 22 divided by 2 is 11, and 10 divided by 2 is 5. So 11/5 is our final answer. Let's try that again. Very good. So which part there do we struggle with? So something you have to remember how to do in this problem is you have to be able to convert from a mixed number to an improper fraction. You also have to remember that a whole number, that an integer to be written as a fraction can be put over 1. Then we have to be able to recognize that division can be rewritten as multiplication by keeping the first fraction the same, changing division to multiplication, and flipping the second fraction. Because dividing fractions is as easy as pi. Flip the second fraction, then multiply, right? Okay, so let's do an application or two. How many times would you need to fill a 2/3 cup container to measure 4 cups of apples?
4 couldn't take away 2 and 3 cups.
Whoa, hang on.
Multiply 4, we got to divide 4 into 2/3.
So how would we do this? We know that we have a 2/3 measuring cup, right? And we need to get 4 total cups.
2/3 divided
Divided
by
by
4
4.
over 1.
4 and 1, yeah.
2/3 divided by 4.
Then you go multiply
Divided
3
by
over
4.
2.
And I'm going to write it as 4 over 1, right?
Mm-hmm.
Man, y'all are fast.
I got
So
the calculator.
2/3 times
2
1 over 4. Do we want to simplify here? Do we want to reduce here?
You said always later.
It's totally up to you.
Okay, we can.
The 2 and the 4 can simplify. So divide both sides by, or both 2 and the 4 by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2.
Maybe 1 over 6.
1 over 6. Wait. Have we done this right? That doesn't make sense, does it? Okay, so here's a point where I want you to pause and think. Does it make sense that I would be able to fill up 4 cups of apples with 1/6 of 2/3? All right. Now it's time to scratch through what we did. You want to fill up 4. So you actually want to start with 4 over 1. And you want to figure out how many times it will take 2/3 to fill that up. In other words, we want to divide by 2/3. Okay? I want you to recognize that though that first way didn't make sense. And seeing that it was 1/6 should tell us that it doesn't make sense. So again, we're going to keep change flip. And again, we can reduce. Let's reduce at the end this time just because it looks different. What's 4 times 3?
12.
Over,
2.
which reduces to 6 over 1, which is just 6. So you need to fill it 6 times. Now you may notice that the difference between the 2 answers we got is just the reciprocal, right? That's not an accident that happens. Mathematically, it has to be that way. Now, I'm going to show you in a picture how this actually works. So if we take 4 cups, let's pretend those are cups, and we divide each of those into 2/3. Okay? Or into thirds, rather. So how many groups of 2/3 do we have? Well, there's one, right? Let me not write it that way. So there's 2/3, there's 2/3, there's 2/3, there's 2/3, there's 2/3, and there's 2/3. So 1, 2, 3, 4, 5, and 6. For those of you visual learners out there. Any questions? Word problems are where it gets hard, right? With everything. I think we have, do we have one more? No, we have 2 more examples. Okay, it takes 3/4 of a teaspoon of cinnamon to make 1 batch of apple crisp, and you only have 6 teaspoons of cinnamon left in the cupboard. How many batches can you make? We're going to take the bigger number, right? We're going to take 6 over 1 and divide by 3/4. Do we know that's the right way to do it? Because you're taking the bigger number and dividing by the smaller one. Someone who hasn't talked a lot today, tell me what our steps are. Someone who hasn't talked a lot today. I know you know you're not on that list. Of all people. Anybody?
You take the 6 over 1, multiply it with 4 over 3, and then you can multiply 6 times 4.
Which gives us 24, and 1 times 3, which is? Okay, what's 24 divided by 3? You're almost there. A little bigger. 8. So how many batches can we make? 8. Anyone here make apple crisp? You do? Okay, last example. A teacher conducts a poll to determine her student's favorite color. The bar graph shows the result of the poll. Notice that red is 3, white is 2, blue is 5, black is 3, and yellow is 1. So, what fractional part of the class chose blue as their favorite color? Okay, so chose blue. Blue is 5.
1/5. No, I'm
How many total do we have? So it's part over total. And what's our total? How many students do we have? 3 plus 2 is 5, plus 5 is 10, plus 3 is 13, plus 1 is 14. So what part chose blue? 5. 5 over 14. And that does not reduce, right? So 5/14 of the students chose blue as their favorite color. Any questions, comments, concerns, criticisms, donations, what ifs? Okay, that is the end of section 1.4, operations with fractions and mixed numbers.